Hey, it's Mike again. Got something I've been working on for a bit here, a new idea for an app that I think would be pretty cool. I'm a fledgling artist, and I can do some line drawing stuff, but I really stink at color. So I've got an idea for a application that would help me, might help me learn color better, color theory in general. The first part of that, the first feature for this application will be to take the colors of an image and list them out. And you can see what different colors are in an image. I know this is done in other programs, but that's just feature one of a couple, and that's where I was going to start. But to do that, I don't think it's that hard of a of a problem to figure out. But as a programmer, I still like to have that um, uh, uh, confirmed test saying that yes, this is working as expected. Now I've pieced together some prototype code. It was a mess. Maybe I'll show it off sometime. And I got to a solution that I think will be a bit brute force, but at least will get me going and started on an overall solution for the idea. So sorry, you're looking at a blank screen here, probably not all that exciting. But what I thought I would do is primarily what this video is going to be about is using test-driven development to figure out how to do this feature of going pixel by pixel through an image and determining the what I've called a color map. So it's going to tally up all of the different colors that are in an image and then give percentages for each. And I think it's called a histogram. No, it's not called a histogram. I don't know exactly what it's called. I've seen it before in other apps. But anyway, I'm going to make my own version. And I thought I'd spend some time talking about test-driven development and why it's a good idea in this particular problem. One thing that test-driven development gives you is a specific target to code towards. And it can also, once you have the tests in place, it can speed up the implementation test cycle as opposed to like a usual app development when you've got a phone or a device and you're doing UI and you're coding some UI and you're putting in some inputs and you're seeing that it works and back and forth. And that can take a lot longer than just having a really solid unit test and working towards that. The problem is that again, doing a full scale image, there's like thousands of colors in there, specific RGB values, and there's absolutely no way for me to confirm that those values are correct. So what I plan to do, or what I've done, this is kind of a bit of a reenactment because I have worked through this already. But I'm going to build a image by hand, and then I'll use that as a well-known destination to code the solution to. So here we go. The library that I'm going to use is called this image library that I found, and it is a in the Dart pub site, and I went ahead and namespaced it so it doesn't conflict with any possible Dart libraries because there's similar colors and other class namespaces that could conflict. So anyway, so the actual test that I'm going to do is again I'm going to create an image by hand. So let's do that image, and it's going to be an image. Whoops. Yes, I had it right there. And it's going to be a 2 by 2. So super small, very well defined. and I can be really confident that the code I built eventually will actually deliver the results that I plan for. So with this image, I'm going to go ahead and do a couple commands here for the image. I'm going to fill the image with, let's call this blue color. And that doesn't exist yet, but then, so I will do a final blue color equals, and we're going to do the image library again. And one thing we can use is this get color command. That's pretty cool. And we know blue is no red, no green, and max blue, which is 255. And then alpha is inferred here to be 255 max. So if I go to this definition of the class, then I can see that alpha is indeed 255. So there we go. We've got a blue color. And then I'm also going to create a red color. And it's going to be 255 red, no green, no blue. Okay, and so then what I'm going to do, again, simplest solution here to just kind of get the ball going, get the ideas. I kind of liken programming to that's anywhere to sketching, because when you're sketching drawing, when you're trying to figure out what you want to draw, or maybe you have just a general rough idea, or you're trying to draw a landscape that you're looking at, you kind of just fill stuff in and play around and see what works. And you don't really know everything until you're kind of most of the way there. And I've already messed up. This needs to be a test. And we are going to do something like ensure color, I called it a color map, returns expected values. And then we're going to create a body here, which is that guy and that. Got one too many of those, remove that. Where's the cursor? Where'd you go? There it is. And then here, go to the end. So now we have a test. And so we've got this image, and what we want to do is we want to say there's a color map, and it's going to be from color map. And this is kind of one cool thing about doing this in a test file, is that I can just kind of use this as a canvas, speaking of drawing and colors and all that stuff. I can just use this test file as a canvas to build out my code. So eventually this will go into the files over here under lib, but for right now I can just build it out in this area here. So I called it construct color map, and it takes an image, come on, spell right, and it's going to be the image, and it's going to be that, and that's actually going to, so what this color map is going to do again is it's going to be constructed via by going through the all of the pixels in the image and determining how many of each there is, each color. So there's going to be a map, and it's going to be an int of ints. So what I'm proposing is that we create this color map that will contain the first, the key value will be the color, and it's a 32-bit int. I think I've got that right. And then there'll be the total of how many colors that is. And it's going to be a map. And then we'll return that color map. Okay, so I've got the very basics here. There's a reason why I construct, because I'm not spelling it right. Construct, and so I know I've got the signature of what I'm building, and then I'm passing in my initial object here, And now I need to determine if what I get back is correct. So we're coding to failure here first, and then we'll jump into the code and actually create the color map, the solution. We'll create the solution until it matches what we expect the test conditions to be. So from what we've built here, we expect that the color map is going to have two colors. It's going to be red and blue. Those are the only two colors that we have in this image. And then we expect that color map for our red color, because we have, red color is going to be something. Let me just put this here for a placeholder. So we've got this red color, and again, this get color takes that red, green, blue value, and it does all this fancy math. Actually, I think I want to go over that at some point in another video, because doing this forced me to learn some of my binary and hex math that I think would be cool to create a video on. So anyway, it does this math, some bits. What's that term? It's a bit sliding. That's not the right term, but anyway, and it creates this integer that represents this specific color. So this integer will then be the key to the color map for red, and it has, out of a 2x2 image, it's in one pixel, so it's going to be 25%. Because if 25%, because if it was sorry, that's not right. It is going to be 1. It's going to contain 1 pixel. That's what I should have said. And blue is going to be the remaining 3 pixels, because we filled the whole image with blue and then we drew 1 pixel of red, and so that's what we expect. So if we run this, it's gonna fail unless gremlin magic happens. And yep, cool, perfect. So that's what we expect. The actual length is 0 because our color map is of 0 size. So we have this image, and again, this will probably be what I would consider a brute force solution to start with. I have some ideas about maybe doing it a little bit more elegantly, but getting the brute force solution first can at least give you something to work towards. And sometimes the problem space of a problem can be so large that my brain just can't hold the whole thing, and so just working towards something is so helpful for at least me to get some contextual construction of the problem space. So we've got this thing called width, and that's going to be the width of the image. We got the height of the image. So we're going to go through each. We'll do it this way. This is just a very standard for loop here. I keep on typing widget. Fingers are taught to type widget. And I don't do these types of for loops that often anymore. And then, so we're going to go through the width. And then we're going to go, I don't need to copy that, for int y point equals 0, y point less than height. And for all you algorithm people out there, I'm sure you're cringing because you can think of a million ways to do this better. I don't doubt that at all. Again, brute force solution just to kind of get something going. And one cool thing is, if this ends up being super inefficient, if anything, it'll give us a, wow, we've got this huge image and it has a million colors, I don't know how many, and it takes X long to process. So then we know that, okay, well, there's an upper bound, and we can try that on different devices and different processors, and just use that as a benchmark to say, okay, well, this is the worst it's going to be. So anyway, so we're going to use, we've got a pixel. This is a command from image.get pixel, and it takes an X point and a Y point. Now, the reason why I use X point and Y point is because if I use X and Y, and there's X and Y's all over the place. Here's an X in pixel. I'm sure there's some Y's in here. If I do a search for any of those in a big, huge file where I'm trying to find those X and Y values, it's going to show up a whole bunch of different letters or search results. But here, I know that I can more uniquely search for X points. So that's why I do that. So anyway, this gives us, what does it give us? I think it gives us a color. Get the pixel. Color is encoded in, yep, there we go, a 32-bit as that guy. Yeah, cool. Right. And so that's an int, and that's the pixel. And what we're going to do is we're going to go, now we need to add this pixel to the map. But we've got a couple conditions here. The map is empty now. It has no keys, no values. So if first we're going to search through this map, and we're going to go color map.contains. If it contains the pixel, then we're going to go color map pixel equals, and I haven't been anyway, +1, and right. And the thing about this is that we, since we know it contains, we're running against a null here, a null check. But we've already checked to see that it contains that pixel, so we know for sure it's there. So I can go ahead and force that null check, or ignore the null check. So we're adding 1 to that pixel. Else, we're going to go color map at that pixel, and we're going to say equals 1 because it's the first one. We're not starting at 0. We're going to start at 1. And there we go. Again, I'm kind of cheating here because I have gone through this before, which is a good thing because before there was a lot of wrong turns and cussing, and you guys don't want to hear that. So anyway, here we go. We're going to run it. And hopefully, since we have that test, it looks like that it's working. We got a green check mark. That's all happy. So we know at this point that via this function, construct color map, because we had these tests beforehand, we could have, I could have made a whole bunch of mistakes here. And I guess it would have been more dramatic if I would have. Maybe at some other point, I'll go completely blind into some construction. But I used this test file to build out this solution, and I had a well-known test beforehand, and so now I have a solution that's going to work that I can play with. One other thing that I did do was to do a well, actually, let me do this. This is kind of fun because again, this is kind of we're trusting this test, and it feels right and it looks great, and it's testing well. But to have a visual is pretty cool, and I have this really simple method here. I'll go ahead and just cut and paste it, and it's going to take a file, right, dart.io, and so what we're going to do is, and I'm going to take this, right, I could do both of them. I'm just going to do this. Right, so I like to keep kind of my test. This is the test object for this test. If I was grouping these, maybe I would take the test out, or this object out, and use it everywhere. But here it feels a little like I want to have this. And so, yeah, I guess the prior cut I was doing that by hand. So now we're doing it this way. And what this will do is pretty cool. So I can run that. It's going to hopefully just run just fine. Yep, it runs fine. There's no tests or anything in here. I'm just using this test as a place to run this code. And I've got this test PNG here. It's in the same, well, no, it's not in the same. I guess it uses the root of the project to save it to. Yeah. So here's our guy, and there it is. So we're going to explode it up a bit. And there we go. We've got one red square and 3 blue squares that this code built. So now what I could do is I could actually read in. I could keep this test.png as my test criteria, and I could use that instead of building it by hand here and have yet another use case or another test case to build this out. One other thing I did want to do here is I haven't tested the zero condition, which, I mean, in this case it's pretty obvious that we've satisfied, because 1 plus 3, 1 here plus 3 is equal to 4, which is how big we made the image. But just to be on the safe side, what I want to do is I'm going to create another color here, and we'll go with obvious one maybe, and we'll grab that, put this guy in here, and we're going to say we expect that green color is 0, just to be sure that we're not doing any funny stuff when we're constructing this map. We may accidentally do something, although, you know, this length pretty much inhibits this happening. But it's nice to have another safety measure here, and it may be good in some other cases to have this sort of testing that there are none of another color. So there we go. Oh, we're gonna run it, make sure it works. We're not gonna run the whole thing because that would rerun this guy here. And oh, there we go. And there's one other thing that test-driven development can give you. It's to really understand your test space. And so, my bad. This is null, I think, is what it is. And we will run that. So, yeah, I learned trust those tests, because they're usually right. Although you have to watch it that if you change your code, then a lot of times your test breaks because they had other expectations, and so you'd have to change the test to match that. So there we go. Hopefully that was a little constructive, and hope you're enjoying the videos so far. Yeah, I think the next video I want to do is on this color. How I kind of find it fascinating, the math, the numbers that go along with taking these RGB values and constructing a 32 32-bit integer from that. So anyway, thanks for your time. Have fun coding. See ya.